Next up, we have John Gilhuly from Arize, who's going to be talking to us about LLM observability for agents.
Hello, everybody. All right. Hello, everybody. How are you guys? Thank you for joining. As you John said, my name is John. I'm a developer advocate at Arize. Just curious, who's heard of Arize before? Who knows us? Okay. It's a good amount of hands. Okay. For anyone who doesn't know us, I'll do like a quick kind of 2-minute thing, and then we'll jump into the agent-specific and evaluating agent-specific side of things for the presentation. So for anyone who doesn't know, with Arize, basically we are a LLM and general ML CV observability tool. So we help you build different AI applications. We do everything from observability, kind of tracing, evaluation, help you with kind of trying different prompts, experimenting with different iterations of your application, and then in production, managing things like monitoring, guardrails, a bunch of other stuff like that. So there's a lot that we do in here. One thing I'll call out on this slide is we also have a co-pilot that we built into our own product. So we actually built an agent into our product as well. And a lot of our learnings around evaluating agents have come partly from that experience and then partly from working with a whole bunch of different clients as they try to set up AI agents around the world. And we work with a lot of different companies as we do this. So with that, I'm kind of curious, before we jump into the agent side of things, who here has actually like built an agent before, just experimenting? Okay, good amount of people. That's awesome. Awesome. So we're going to talk today about a little bit about agents to kind of set the stage, and then jump into different evaluation techniques that you can use to evaluate an agent, to improve it, to kind of understand where it's performing well and where it might be performing poorly. To level set, just for anyone who hasn't necessarily built an agent, one of the main kind of patterns that we see when folks are actually going out building AI agents is what you see up on the side here, where you're using some sort of router, so some kind of initial step to determine where your agent's going to go, some kind of routing or planning step. This can be everything from full LLM with function calling that you're using. It can be just a BERT classifier. It can be a few different other kind of approaches. But basically, that's what takes a user input and then decides what kind of skill or what kind of function or what kind of path is your agent going to go down from there. So you have that kind of initial router step. And then a lot of times you'll have function calls or skills or things like that that accompany your agent here. And so with those will be doing the actual work of your particular agent. So they're actually going through, you might have a full RAG skill. You might have like calls to external APIs or internal APIs or whatever else it might be. But oftentimes you'll have those kinds of steps. And then you might go back to your router. You might just go right to a user with the output. You might kind of go through multiple different analysis steps. Oftentimes you're going back to the router and you're kind of creating that loop where you have that sort of more agentic kind of loop of behavior. I'll mention not every agent uses a router. There's all kinds of different architectures. We could have a whole debate about like what's an agent and what, like when does something become an agent, and we don't necessarily need to go down that loop. This is kind of a common structure that we've seen, and as we think about evaluating, it's a good one to think through. But so just to look at it one more way here, this is kind of a typical flow that we end up seeing with programs where they're going router to a skill, and then maybe to some sort of self-reflection step, or going back to a user or some other kind of step from there, and then continuing to go back to the router and the skills and kind of looping back and forth until they eventually get to a response for a user. All the while, they're also going to be interacting with memory and state and kind of accessing context within each of those different steps to kind of help it along as it moves between those different skills. And so to put a little bit more of a real world example here, say you had a chat bot that you were putting onto an e-commerce site. That bot might use a LLM kind of call initially in the router stage to do its kind of function calling and deciding where it should go down a path. And so in this case, we use like an OpenAI router, and then that classifies the user's initial input into one of a few different skills that it might use. In this case, either like an item search skill, a question answering skill. You might have other ones from there. And then in those skills, you might also have further LLM calls. You might also have calls that are made to models. And that's partly where things get even more difficult to evaluate, because you have these nested different non-deterministic inputs and outputs that are coming through your whole pipeline as you go. And so this is kind of a very basic example. You can imagine as you go into production, you get much more complex real world examples. This is a real agent that is deployed in the wild right now. I won't tell you for what company, but this is one that really does exist. And it's still got that same kind of structure where you have an input, the router function, and then in this case, one of 5 different skills it goes down the path of, with all kinds of fun stuff that happens within each of those skills. Everything from LLM calls, API calls, just application code. So all kinds of different stuff. And you can imagine when you're going to evaluate how this performs, it can get really confusing and complex to actually do. So it's a little bit of background on kind of what agents are, just get everybody on the same page for that. I want to spend most of the time we have talking about how you actually evaluate them and why evaluating them is so difficult. And so there's a few things that come up here when you're thinking about why it's so hard to evaluate these. I mentioned the non-deterministic element. That's kind of just a general AI difficulty when you're trying to evaluate the performance of an AI system. The non-deterministic element of LLMs makes it hard to do. Not really specific to agents there, but it is something that comes up and does get kind of compounded in the second case here, where a bad response somewhere within your agent's flow can kind of percolate through the rest of your agent to give you even more confusing responses later down the line. Because you imagine you get a bad response or an incorrect response on a step way down your agent's lifecycle, that then goes into multiple other LLM calls and things like that. It just becomes this weird game of telephone where you have the whole sort of output that you get has been mutilated a bunch of different times along that path, which can be fairly frustrating. The other big piece of this is that agents are taking a path that they're determining at the time of execution through their own execution kind of path. So if you have an agent that's executing here, it's making a decision on which route to go down. It might loop back and make other decisions on which route to go down. And so you can end up in cases where agents take really inefficient paths to get to a solution, even though the actual output is right. So if you're looking at the output of an agent, for example, and then you see that the output is correct, you might think that that was a fine run of your agent. But then you actually go into the details and you see that that took 14 loops through your agent's lifecycle to actually get to a solution, and it should have taken 3 or it should have taken 2. So that element of efficiency and how it executes is really hard to understand. And the last one, this is sort of my own take, but I think there's a lot of frameworks that make building an agent really easy to do, especially as you get started with things, and there's a lot of examples that are out there, but it can make debugging harder as you go. So if you're using frameworks that obfuscate some of the what's happening under the hood, that makes things easier to build, but then it can make things a little bit more difficult to debug. So as an example of that, this is like a 20-line agent that has multiple different skills that's attached to it. Super easy to define and to build, but then if you go try to execute that agent, there's a lot that happens behind the scenes. So that one call at the end to invoke our agent is sending it through all these different kind of spans and execution steps that you see. And so if you don't know that that's what's happening behind the scenes, you might get strange responses and not really know why you're getting those strange responses. So that is a bunch of the difficulties of doing it. So how do we actually address those? How do we evaluate agents? We're going to talk a little bit about the how and a little bit about the what. So what pieces of the agent do we evaluate as well? On the how, this is kind of the general flow that we'll go through, and we'll go through each of these steps in a little bit more detail too. But essentially, step 0 is adding observability, so giving you some visibility so you can have stack traces that look like the one on the right over there, so you can actually see what's happening behind your code as you go through and as you build things. So having observability is sort of step 0, because any evaluations you're going to run, or a lot of evaluations you're going to run, are going to be built on all those traces that you capture, all that evaluation or all that observability data that you've collected about your application. So once you have that, then the step goes from there to basically say the next step that you would go for is to build up a set of test cases that you're going to use to evaluate the performance of your agent over time. These don't have to be thousands and thousands of test cases. Our recommendation is you have try to go as broad as possible to cover the different types of inputs that you might get in your application, but you don't necessarily need 10, 15, 20, 100 different iterations of each of those examples. You can have a set of test cases that's 100 examples, and that covers the types of inputs that you would receive in your agent or you expect to. And you can build up this set of test cases over time as well too. So this is something that you can kind of create an initial set, and then as you're taking your application out into production or out into testers or whatever it would be from there, as you see new kinds of inputs that you're receiving that you weren't expecting, you can add those to your list of test cases so you continue to build it up over time. Once you have that, then you're breaking down your agent into individual steps, and we'll talk about kind of typical steps that we see for that in a second, and breaking them down into kind of individual logic steps and jobs that your agent has to do that you can then evaluate. So then you can create different evaluators for each of those steps using a couple different techniques, and from there, experiment, iterate. What I mean by that last step too is if you have a set of test cases and you have a set of evaluators, you can actually modify your agent. You can swap in new models, new prompts, new code. And then if you keep the evaluators the same and you keep the test cases either the same or growing over time, then you can have more comparable runs of your application, and you can kind of have a sense of surety that you're not breaking something in a different part of your application by making changes to one part of it. All right. So before I go to any pieces, let me actually just pause and see if there's any questions as well too. So this isn't just me talking at you guys for 25 minutes. Any questions on what we've covered so far? Otherwise, I'll keep going. All right. If there are questions, feel free to just raise your hand as we go too. You guys can interrupt me, whatever it is, as we keep going, because we're covering some ground here. So I mentioned we're going to cover kind of the what as well as the how. To start with the what I mean by that is kind of what pieces of an agent should you evaluate? What kind of individual steps within an agent, when you're building an agent, should you focus your evaluation on? There are a few that kind of come with traditional LLM evaluation, which is a very funny phrase to say out loud now that I've said that, because traditional LLM evaluation is like 2 years old at this point max. So the skills and functions evaluation that you see in the middle, that's where you're kind of evaluating individual functions or things within your application that are kind of completing the work. So after your agents decided which step to go to, the actual code that's completing that particular step. So I mentioned before, if we go all the way back actually really quickly to our example here, the skills and functions are kind of these 5 things that you see here. And so there is an element of just evaluating those, making sure that once your agent's made the right decision of which path to go down, that is all functioning correctly. Again, you might have LLM calls within that. So you might be doing things like evaluating the relevancy of responses from your RAG skill that's within your agent or something along those lines. So everything that you do to evaluate normal LLM systems, you can still do to evaluate the agent systems. And that kind of gets grouped under that evaluation of the skills or functions of the agent. So that's the piece that kind of comes with traditional LLM evaluation. The router and the path are kind of the more unique ones to the agent side of things. So with the router, what I mean by that is you're evaluating basically if you're using a router, which again, not every agent does. If you're using a router, you want to evaluate whether or not that is making the right choice of which branch to go down within your whole agent. So if I look at the router, there's kind of 3 jobs that a router would have if you're using a function calling router here. You'd have a job of choosing the right skill. So choosing the right kind of path to go down based on the input from the user. So does it pick the right path? And then what those paths are oftentimes is actual functions that are being called. So there's an element too of, does it pull out the right parameters from whatever the input was from the user? If we go back to the kind of chatbot example for an e-commerce brand, the user might say, can you give me the status of my order? The order number is 1234. Your router needs to know to go down the kind of order status path. It also needs to know to pull out that particular text as the order ID and as the right kind of parameter there. So there's an element of choosing the right parameter to pull out of the user's question. And then there's a final step that we talk about sometimes of function generation, which is actually going through, and now that you know the path you want to go down and the actual parameters you're going to extract, generating the right code to go do that. Transparently, that usually works. That step, the actual function generation, if you get the other 2 pieces of this right, the actual function generation part is almost always going to be correct. The parameter extraction is oftentimes the hardest part for some of these models to do if you're using an LLM as a routing system here. So when I talk about evaluating the router, these are kind of some of the things that you would look at to evaluate and to kind of decide on how it's performing. And then the third one of these is path. So what is the path that your agent takes through, not just choosing the right skill, but how many iterations are you going through? How many loops are you going through? Are you making progress towards a goal with each selection that's made? And are you avoiding steps where an agent might loop infinitely, which can happen? I'll say often, a lot of times there's checks you put in place to prevent that from happening, but there are a lot of cases where agents will loop indefinitely. So these are kind of the 3 areas that I think about of what are you going to evaluate within the agent, your router, your skills and functions, and then the actual execution path that it goes through. And so with that, let's talk a little bit about, I kind of mentioned the converging piece. Is it making progress towards the goal? Let's talk a little bit about how you actually do some of this evaluation. So now you know what you want to evaluate, what pieces of it. How do you actually run, like what are the techniques for running those evaluations, and what are those techniques for actually measuring that performance? I've got 3 up here. I'm going to focus on the first 2. Happy to talk about data set analysis one-on-one if anyone wants to go into that. I use these groupings to kind of think about the types of evaluations that I might run. There are a lot of types of evaluations, so this is just one way of grouping them together. But I kind of group them into ground truth and then LLM as a judge as 2 main techniques that we use for evaluation. So with ground truth, if anyone's done any kind of like traditional data science or worked in ML previously or anything like that, this is probably the most familiar to people usually, is the assertion-based or ground truth evals, which is kind of a broad label for cases where you know what the actual expected output for a given input into your model is, or into your agent is. So if you put in what's the status of my order number 1234, you know what function it should pick, you know what parameters it should extract, you know what kind of path it should take. And so because you know that, you can then actually calculate things like false positives, false negatives, F1 scores, precision recall, a lot of the stuff that you see on the left side over here, where you're looking at basically, does the expected output and the actual output I got from my agent match? So are those 2 things connected there? And then you can obviously calculate things like similarity scores or Rouge-1 scores if you're doing more of a soft match of, is the text from my agent roughly the same as the text that I was expecting, for example. So there's a bunch of comparing expected outputs to actual outputs. And then on the sort of far on the right side over there, I think I reversed that correctly. On the right side over there, then you're looking at the comparison of the distribution of outputs to the actual distribution of outputs you got. So I've got an example here of KL divergence. Basically what we're looking at in that case is you might know for a particular application that you've set up that you expect about 10% of the outputs to fall into this car category. You expect 5 to fall into the credit card category. And you can look to see, okay, does the total distribution of the outputs from my model match that? Do I have about 10% in that category? Do I have about 5%? So basically with these, you're comparing either the kind of expected outputs and the actual outputs either at a granular level or at a kind of distribution-wide level in either case. You could do a whole presentation just on these different techniques and a bunch of different ones in here. There's a bunch of ways you can use these kinds of techniques in different versions here. The main idea, though, is that you're comparing a ground truth to what your model spit out. And so there's a bunch of ways you can do that, but that's the main kind of grouping of these. And that works really well when you have a ground truth. If you don't have that ground truth data, it gets a little bit more difficult. And sometimes you might want to evaluate things that don't really work for that sort of setup. You might have more qualitative evaluations that you want to do. Say, for example, if you're trying to evaluate whether or not the RAG skill in your agent hallucinates, then that's a harder thing to write a kind of a ground truth comparison test for. That's where you might use the other technique we had, which is the LLM as a judge side. Is this familiar to anyone in the room, the LLM as a judge? I see some hands. Cool. I feel like it's the same people who built an agent, so I think we're seeing some kind of commonalities there. For anyone who's not familiar, the way an LLM as a judge works, it's the same idea, or it's, as the name applies here, it is using a separate LLM as a judge to evaluate the output of your application. So typically what you do is you pull, say, the input to your application or input to a particular step, you pull the output as well, and then you construct a new kind of template out of those two and send it over to a separate LLM to evaluate one specific criteria of that. So hallucination is a great example here, where say you've got a RAG skill within your agent that you're doing. You want to pull out the input from the user, the context that was retrieved, and then the response that your skill put out. You're going to send all of those over to a separate model and construct a template, kind of like the one you see down here, where it's saying, is the response based on this context and the query, is there any kind of hallucination present in that response? Or is all of it supported by these two other things? And that works because you're really stripping down and focusing the second LLM on that particular question. Whereas your other kind of LLM call that you made had to do a full generation step and kind of all those pieces there. In this case, you're just telling this other one to look specifically for hallucination. So it's able to kind of focus in on that particular area and assign a either hallucinated or not label to that. This is another kind of showing the same sort of thing in a little bit more detail. I like to pull this one up because it gives you more of a realistic template of what this would actually look like. So in this case, this one's using whether or not the reference text that was pulled is relevant. So it's looking at the query and the reference text, and it's saying determine whether the reference text contains information about whether it can answer the question. So same idea, you're pulling those sorts of information, sending them over to a separate LLM, and then having that separate LLM actually make the call for you. This is really powerful and really helpful, especially if you want to do more qualitative evaluations or you don't have ground truth data to compare against. However, it does come with some caveats, as you can probably imagine. One of them is that if you really want to do this kind of and have any sort of, I say accuracy, but it's really alignment to what a human judge would use, then you kind of have to use the largest models to do this. There's a great paper called Who Judges the Judges that goes through a bunch of kind of detail on this and benchmarks a bunch of different models. But each of these will go through and kind of show that if you use GPT-4 or 4.0, it's going to perform pretty well. If you use smaller models, it gets a little bit more difficult. You can use fine-tuned models, and that's a whole other kind of topic to go down, which is kind of a fun one as well. But generally, you have to use large models, which then also comes with an element of you're incurring additional cost. If you're going to run these kinds of evaluations at scale, you have to kind of have the infrastructure set up to run these particular types of evaluations. So LLM as a judge is great. I think in practice, ideally, folks would use both of these in a production kind of use case. So if we go all the way back here, you can imagine that if you're looking at some of your different evaluations, the router step can work well with a LLM as a judge or ground truth, depending on which approach you want to use. You could have a built-in input and then an expected output for a function choice, or you could use an LLM as a judge. Skills and functions are also going to depend. If it's a RAG system, you might have a combo of both. If it's a external API, you could even go down to like unit tests if it's an external API. So you don't also have to use either of those techniques. There are more traditional software engineering things, especially for the skills section. When it comes to the when it comes to the path is more difficult, and transparently, most of the time with people in production, they are spot checking this a little bit more versus doing really scaled kind of analysis of the path that was taken. Typically, what we'll see a lot of people do is actually just measure the number of iterations or cycles that each query takes through the agent, and then using that to kind of go in and spot check from there. You can use an LLM as a judge and feed in the whole path that was taken and see if that was the optimal path and whether that worked out. It's just very hard to structure that prompt appropriately, and it's very specific to whatever kind of application you're doing. So you can see you kind of use a whole combination of all of these different techniques as you're going about really fully evaluating an agent there. And with that, I want to just kind of do one quick, I've got a little video that shows a little bit of a demo here. It's always kind of fun to see what this looks like in platform. I'll say before I even show this, basically everything I've talked about so far is like conceptual. So nothing that you need to use Phoenix or Arize for. But I'm going to show you guys Phoenix, which is our open source platform, but you could apply all those concepts to whatever kind of framework you want to use. So I will throw that out there as well. So what we're looking at here for this example, I'm going to show you what a couple of the evaluations look like in platform as we run them. This is basically that same chatbot example that we showed earlier. So you can see we're looking at different inputs and outputs. Each line here is a full run through of the agent. And you'll see as we, of course the video is difficult. And you'll see as we click into these, it's going to pull up the full run of the agent. And you can see there's some, we've added some labels here under evaluation for function call and parameter extraction. So 2 of the LLM as a judge kind of evaluations that we ran. And one other thing I'll call out that's really nice here is that you also get, with LLM as a judge, you can instruct it to give you an explanation of why it made that particular choice, why that label was chosen by the second LLM. So that makes it much easier because if you're trying to go, you don't have to go parse through all the different information and find, say, the hallucination or the incorrect function call or why it was incorrect. You can just at a glance see, in this case, okay, the user's question was about promotions for a smartphone and they made a function call to do a product search as opposed to like a promo search, which was a function we specifically had. So you can see that that's the case where this one's messed up. And I got to stop doing that same button, but so you'll see that those get added in, those explanations there. And those get generated with LLM as a judge, which makes it very easier to kind of do any sort of spot checking that you might do. And so you can see it's calling out that piece there. And then I didn't really mention necessarily what to do once you've collected some of the offending cases. So one thing that this is showing here is actually going through and creating a data set out of the examples where you've maybe failed. And then you could take that data set, go use it for further testing if you wanted to. You could run some experiments against that particular data set. So you can see in this case, this is going to show an experiment that was run for that particular data set where we've basically taken each example in the data set, piped it through your application, and then generated the labels for each evaluation. In this case, we're just looking at the router. So it's that parameter extraction, function generation, and function routing that are going to be calculated for each one. And one nice thing is you can kind of then compare these side by side over time. So as you want to run multiple different iterations of your application, you can look line by line, side by side at the different evaluations that are generated by each of them. And with that, the last thing I'll kind of leave with here is just, I've touched on a couple things that we do within Phoenix and Arize. There's a lot more that I haven't really talked about. So covering everything from more kind of production monitoring, prompt management and playgrounding, a whole Copilot agent that I kind of mentioned, but we didn't necessarily go into. If anyone hasn't tried us out yet, Phoenix is a great tool. It's open source and 100% free. So feel free to check that out. I'll put up a QR code in a second here as well too. But again, there's a bunch more in here that I haven't necessarily had a chance to talk about. And with that, I'll take some time for questions. Actually, yeah, let me take some time for questions and then I'll do my last little rigmarole. Any questions on anything we went through here?
So
I'll give you my mic.
Hey, I'm Atai, co-founder and CEO of Copilot Kit, also open source. So great talk, first of all. So you showed us all the evaluations for essentially build time of the agent, right? As you're constructing the prompts, you can figure out if your prompts are good while you're building the agent. Do you guys have any existing or planned extensions for the runtime? So while the agent is running, you can figure out, hey, there's a mistake here, and then surfacing this somehow.
Yeah, definitely. So a lot of those evaluations could also be run at runtime as well too. So once you've got the agent in production, you could kind of, what we usually would recommend is on a regular basis, basically pull out logs from the past X amount of time or a sample of logs and run some of those evaluations there as well too. So you can still use some of those in production. I think there's a couple other tools that we use in production a little bit more. One is actually running any of those evaluations online, and sort of as the execution is going. You can do that with certain kinds of evaluations without blocking the execution thread, which can be helpful. And then there's also kind of a subset of that, which is guardrails, which is more like, as opposed to evaluating performance, you're more setting like specific criteria that either need to pass or fail to have a response go through. So this is where you could do things like block any sort of toxicity in responses from your agent. So that'd be attaching like an evaluation to the end of the kind of whole flow there. And you could use similar LLM as a judge or ground truth or whatever kind of other techniques for deciding whether or not something was toxic, but you're using it in a sort of for a different purpose in this case, to block as opposed to kind of measuring performance. But for any of those, we'll show them all on the platform. You'll have kind of rolled up metrics and dashboards and things like that I didn't really show here. That will kind of measure that rate over time. Cool. Okay. All right, cool. Last thing I'll say, please star us on GitHub if you are feeling magnanimous. I've also got socks and stickers. So if anyone wants swag for Phoenix stuff, come find me. I will make you star us before I give you swag, but it's a low barrier to entry there. And as Yujan said, we are hiring for both ML engineers and AI engineers as well as dev advocates. So come grab me if you want to talk more about either of those roles. And thank you very much.